All right, so we're going to continue graphing with quadratic functions. Last week we graphed in standard form. This week we're going to be graphing in vertex form. So the vertex form of a quadratic function is going to look like f of x equals a parentheses x minus h close parentheses squared plus k. Now the h and k should kind of look familiar. When we graphed linear functions, we looked at translations. So whether it vertically translated or it horizontally translated. So the k value is going to tell me how far up or down my graph is going to be from my parent function, where my h value is going to tell me how far to the left or to the right my new function is going to be from my parent function. One more thing you guys have to remember though is that a cannot equal 0, which makes sense because if a equals 0, because a is being multiplied by this entire set of parentheses, that all goes away and we're just left with k. We don't have a quadratic function anymore. Okay, so from this function, from vertex form, we can actually find the vertex right away. So our vertex, all that it is, it's going to be the opposite of my h value, so it's just going to be h and then k. We can then also find the axis of symmetry, because if you remember from last week, the axis of symmetry is just x equals, because it's a line, so we have to write it as an equation, and it's x equals whatever the x of my vertex is. Well, the x of my vertex is my h. All right, so now when we graph, we're going to start with step 1. So step 1, we need to plot the vertex and our axis of symmetry. All right, then we're going to go to step 2. So step 2, we're going to find the y-intercept. And to find the y-intercept, all we're going to do is plug in 0 for x. All right, let's take a look at the example. So we're going to take f of x equals -2, parentheses x plus 1 squared plus 5. Okay, so first we're going to look at the vertex. So the vertex, we're going to take the opposite of my h, which is the opposite and positive one is going to give me -1. And then we want our k, which is 5. And that's it. So that's my vertex. So if I plot my vertex, it's at -1, 5. So my vertex is all the way up here. And then we're going to plot our axis of symmetry. We're going to draw our line of axis of symmetry. So the axis of symmetry is x equals the x of my vertex is -1. So we're going to draw a dashed line straight down through our vertex. All right, now to find the y-intercept, we're going to plug in 0 for x. So my function is f of x equals -2. Instead of x, I'm going to put 0 plus 1 plus 5. And we're just going to solve for f of x. Remember, f of x is the same thing as y. So if I wanted to just rewrite this as y equals, we could. So now -2 times, well, that's just 1 squared plus 5. Y equals -2 times, well, 1 squared is just 1. Y equals -2 plus 5, so y is equal to +3. So that means my y-intercept is, when my x is 0, my y is 3, because remember, y-intercept is a coordinate. So we're going to graph that point. So 0, 1, 2, 3. That's my y-intercept. Well, remember, our axis of symmetry, that's a line of reflection. That means that everything on the one side of my parabola, so that everything on the left side of the parabola, is going to be the same as everything on the right side, and vice versa. So everything on the right side of my parabola is going to be exactly the same on the left if I were to fold it in half down my axis of symmetry. So we're reflecting this point the same amount of spaces over this axis of symmetry. So it's going to go right over here. And now we can draw our parabola down. And that's it.